Hello everyone, I would like to welcome for the first session that we have on cloud computing. Today we're going to talk about how we're getting your workload cloud native with Atos Migrate. Okay, quick agenda. So first we're going to introduce ourselves. I see a couple of people that are not from Atos, from other companies, so probably it's the first time with me. We'll make a short introduction to containers and Kubernetes so that we are all on the same page. We'll talk about GKE. Then we will talk about this new product announced by Google, which is called Anthos. We will talk about Anthos Migrate. We'll have a look at how to migrate virtual machines to GCP. We'll show you a short demo how this is done, how we stream virtual machines into cloud. And finally, we'll show you what Google has announced as a beta of migrating virtual machines into containers. And finally, we have some time for QA, hopefully. If we don't have enough time, you can reach out. We'll be around here, and you can contact us on Twitter or LinkedIn. Okay, a short introduction, Krzysztof.
Thanks, Konrad. So I just came back to the role of lead developer in Atos. I'll be leading a team of architects designing a product, hybrid cloud product. I have around 15 years of experience, 11 of those years in the enterprise environment. I'm VMware certified, design expert even. I hold a couple of AWS certificates, a couple of Google Cloud certificates. I finished executive MBA in IT studies. And I'm one of the 3 Polish VCDXs currently. Konrad.
My name is Clapa. I work with Atos for the last 9 years, currently being a global cloud automation architect. I've been working with Krzysztof on our private cloud portfolio for the last 6 years. I mainly specialize in VMware technologies, but I also scope Google Cloud right now. What's interesting, we'll talk later about, I'm a leader of GDG, Google Developer Group in bITconf. And I hope that you guys will join us for the sessions that we have every 3 months. Okay?
As you can see, we have only one microphone, so we'll be passing it over. Okay, let's get started. As you saw on the agenda, we'll be building our knowledge about containerization technologies and microservices brick by brick until we have the foundations before we'll be able to start talking about Anthos Migrate. So basically, what is the container? From our perspective, container is just a packaging mechanism that is there to isolate running applications from each other on one single system. They are running on one node, they are sharing the OS kernel, but they are stripping the whole thing that makes the virtual machine what it is on the hypervisor. So basically, as we are looking on the virtual machine, we have the application, we have the dependencies, the libraries, binaries, but we have also a whole operating system that is responsible for running that application and also responsible for working with the virtual hardware inside the virtual machine, but also working with the hardware of the hypervisor. We don't have that on the container. We have only the application, we have only the binaries, we have only the configuration files. The only thing that we need to be present on the operating system is the Docker engine. It is responsible for scheduling, for creating, for destroying the containers on that system. Let's quickly compare the containers with virtual machines. So there are some pros and there are some cons in running both. First of all, the size. As you saw in the previous slide, we don't have the whole operating system running as we have in the virtual machine. So the gold medal goes to containers. The size is much smaller than the virtual machine. Also, if you don't have to run all the operating system modules, functions, and services, containers are much smaller and they don't require so many resources. Since they are small, the provisioning time is also very fast. So once again, gold medal goes to containers. And since the containers were built around the idea of continual improvement and continual development, the overhead of having that in your environment is much smaller. But also we have some cons in running them. As you can imagine, since containers share the same OS kernel, if that kernel has some vulnerabilities, the security flaws can impact all of the containers. We don't have that in virtual machine. They have separate OS kernel. They're running on a separate virtual machines. So they're running separate software stacks. Also, when we are talking about containers in comparison to virtual machines, the operating system flexibility is much greater in virtual machines. I've seen in my career virtual machines running basically every operating system that is existing right now in the corporate environment. I've seen OS/2O, I've seen NT 4.0 virtual machines, containers, even though you can run them on Windows. Recently, that was announced. They don't provide you that OS flexibility. Also, when we are talking about storage options, containers are much harder to connect to some of the storage. Let's take iSCSI for example. Although you can run iSCSI, open iSCSI on the underlying host, containers will have another layer before they will be able to access iSCSI target. You don't have that in virtual machines. You will be able to connect the iSCSI initiator to target right away. Okay, so we have one single container or a set of containers running on the single host. But if we would like to scale that up, we need another management mechanism to do that. That's why a couple of different companies started creating those management systems. Docker created its own, Google started creating Kubernetes, and actually that management system war was won by Kubernetes. Currently, Kubernetes is not being developed by Google, but by Cloud Native Computing Foundation. Like I said, it is a management system and coordination system for the pods and containers. In its architecture, it is split by half. You have the control plane and you have the actual worker plane. In the control plane, the most important part is the Kubernetes master. It runs a couple of roles. The most important one probably is the Kubernetes API server. It is responsible for getting the commands from the users, from other systems, and letting them, passing them to the worker part. Also, it is gathering backfeed from the nodes and processing them inside the control plane. The etcd is the database. It can be easily scaled up. It is a key value store. We also have in the control plane the kube scheduler. It is responsible for scheduling the pods and containers on the worker plane. And we have the controller. It is also split in half. You have the part that is responsible for running processes on the master itself, but we also have the part that is responsible for controlling the whole setup in the worker area. The worker area consists of nodes. This is the cluster of nodes. Each cluster has a couple of services that are only related to managing those nodes. So the kubelet is scheduling and starting and managing and destroying the pods and containers inside. And we have the kube proxy that is responsible for subnetting inside the node, but also for the communication between the nodes to allow the communication between the pods. So I've been using pods and containers interchangeably, but actually pod is the smallest unit of deployment inside the node. When we are thinking about, for instance, three-layered application, we can split it. In half. We can have the web server and, for instance, the logic inside one single pod running as two separate containers. But we then set up another pod containing only, for instance, the database service. So we can schedule and load balance between multiple pods having the web server and the logic, and one single pod running only the database. As you can see on the slide, Kubernetes in its current version is compliant with HIPAA, so the Health Industry Act, and also with PCI DSS version 3.1.
Sorry, can you elaborate on that? What does it actually mean?
Can we keep the questions until the end? I believe we'll be running late, so if you don't mind, let's talk about that later.
No worries.
Okay, so we have the Kubernetes. Like I said, it was developed by Google, but it's currently an open source product. But Google is now offering in the Google Cloud Platform a managed service based on Kubernetes. It is called Google Kubernetes Engine, and as Google says right now, it is being watched. Your deployments are being watched by 750 different site reliability engineers. So if you are deploying something to GKE, you can expect that these guys will be watching over your deployment and making sure your workload is healthy. Okay, so among the features that are offered by GKE, I believe a year ago, GKE was introduced as a regional resource, so you can have replicas of your nodes and your management control plane inside multiple zones inside one region. Going from left to right, first of all, you can define the state of your clusters by using imperative way, so you're running just a bunch of kubectl commands. And apart from that, you can also run it as software as a code, and you can set up the deployment using the YAML file, for instance. The control plane is very similar to the concept that I just presented. So we have the resource controllers that are responsible for scheduling, for running and making sure that the applications are healthy and in the proper state. We have the scheduler that is scheduling the installation of new nodes, node pools, and user pods. That control plane is also responsible for assigning storage to your user pods. And from the pod perspective, well, like I said, they can be set up in different zones. That is one thing. Google also introduced a concept of node pools. So inside the cluster, you can have nodes that have different configuration. You can run them. You can run different types of server hardware. So, for instance, if your application requires some compute capabilities from the graphics perspective, you can have a set of nodes that are responsible only for running this type of workload. Apart from that, as this is a Google managed service, it integrates with, for instance, VPC networking, load balancing. Like I mentioned, you can assign an external storage. Here, that can be a persistent disk from Google Compute Engine. And of course, what is very important, it integrates with standard driver monitoring and logging. So you have one single way of looking at the current state of your deployments and your clusters. SLA for this managed service is 99.95. Okay. So now another open source project that came from Google. Actually, this one is an open platform that was developed by Google with IBM Cloud and I believe Lyft. It was announced like 2 years ago. So basically, what it is, Istio is its name. It is a service mesh. Service mesh means it is a network of microservices. Network of microservices, since we have a couple of applications running inside the pod, they are called services and they need to talk to each other. So Istio is the overlay mechanism put on the Kubernetes cluster that is responsible for connecting those services together. It actually has a couple of objects that are tightly coupled. On the bottom we have the data plane with our pods and services. Istio deploys the level 7 proxy that is called Envoy. It is responsible. It actually takes over the whole configuration and the whole communication. Hello? Okay, we're back. It takes over the whole communication inside the deployment. It is responsible for the load balancing. It is responsible for mutual authentication of the pods and services inside it. But we also have a couple of other components. We have the pilot. That is responsible for driving those sidecars here and the proxies. We have the mixer that is responsible for getting telemetry from the pods and gathering information about what is actually going on in the deployment. It is also sending out the policies. That's not me. It is also sending out policies to the envoys. And we have the third part that is called a citadel. Like I said, the services can mutually authenticate each other. So the citadel is responsible for allowing that. It is a store for the certificates. It is able to upgrade untrusted communication to the encrypted one. Okay, so let's put that all together. We mentioned containers, we mentioned Kubernetes engine, and we mentioned Istio. So a year ago, during the next 2018 conference, Google came out with a new product. It was called back then Cloud Services Platform. During this conference, next 2019, that platform was made generally available, and we have the name was changed to Anthos. It is a management system for your application, but Google says it's just an umbrella of products, so different products on the hood of that product. Basically, what is the most important part? Of course, GKE, Google Kubernetes Engine. We have a couple of flavors of the GKE. On the left-hand side, you can see the Google Cloud Platform, so the actual public cloud. On the right-hand side, we have the on-prem data center. So in this actual flavor, it is running on vSphere 6.5. We have Kubernetes engine here. We can have Kubernetes engine on-prem, but they can be managed, and you can check out what is actually going on in your deployment using a centralized UI and GKE dashboard. It will allow you to see what is going on in the Google Cloud Platform and also on premises. Google says that the plan is to have the Anthos to be able to manage actually all major cloud vendors. So we can expect that it will be available for Azure, it will be available for IBM Cloud as well. They also want to have the configuration as code capabilities built in Anthos. So these two elements, Atos Config Management is responsible for pushing out configurations to the Google Kubernetes engine and also other parts of the infrastructure. When we're talking about on-prem data center, that configuration management can also be cached locally. And we also have the component of Istio, so the service mesh, running on top of your Google Kubernetes engine deployment. What is worth mentioning here, Istio, this rectangle here, Istio is connecting to the local software-defined networking, for instance, and you can pair it with your NSX deployment if you have it on-prem. Anthos is also combined with GCP marketplace, so you can expect that you will be able to deploy applications very easily from that marketplace. The both sections, the public cloud and the private cloud, can be connected using Cloud Interconnect, but also there is an option for Cloud VPN. And of course, what is very important, both of them are connected to the Stack driver, so you can expect logging and monitoring dashboards to be available for you in Stack driver. Okay.
Okay, guys, so this is pretty important announcement that they got this year, actually, that you can extend your Google Cloud into your own data center. AWS had the Outpost before, but this is something that's actually in production. We've seen that with a couple of customers looking at the beta. So Bank of Canada, for example, they're using GKE on-prem as extension of their Google Cloud. Okay, and a couple of components of Anthos. So you need to understand there are two types of GKE. There is a GKE in Google Cloud and GKE on-prem. And GKE on-prem, it went out of beta. However, there are a lot of cons using this. When you try migrating your workload, for example, the migration with Anthos is currently only supported on GKE. Yeah? It is on roadmap to have the migration on-prem as well, but you need to be aware there are some limitation. Also, if you look at the components that Krzysztof was describing, like the management of multi-clusters or configuration management with policies, this is available on both platforms. When it comes to Istio, again, on GKE in Google Cloud, you have this integrated, Istio integrated by default by just checking a box in the console, whereas on-prem, you actually need to install the open source version. But there are also, logging monitoring and marketplace. This is available for both versions of GKE. Okay, and let's start with the migration to GCP. So what Google says, you have actually two ways to migrate to GCP. You can simply go into GCE, which is Google Compute Engine, which are virtual machines, or you can go to GKE. So the easiest way, obviously, is to just lift and shift your workloads. It's suitable for more types of workloads because it's just copying a virtual machine. So go through the discovery phase first. You find out what applications you have, and then you can start planning which of those applications you want to migrate. And then you have two paths. Basically, you can start creating a landing zone in GCP, create your VCPs, create your projects, decide on your IP schema. And you start the migration, you validate if your workloads are running okay in GCP, and once they're running in there, you can monitor them using Stackdriver or use the Google recommendation to resize your virtual machines to optimize them. And the second way is to migrate your virtual machines and modernize them into containers. You will see how we can do it. So after you migrate your virtual machines to GCP, you can also do this migration. It's actually on the roadmap how to, it's not on the roadmap, you can actually do it already. But it's the same thing. You just need to prepare your GKE cluster, then you migrate your virtual machines into containers, and do the same optimization and operation. Okay, so here you see the possible tracks. So on the bottom, you can see this is what's currently available. So from on-prem, which is basically the most common hypervisor would be VMware, vSphere. So we can go from virtual machines, you can migrate them into GCE directly. You can migrate them into containers into GKE in Google Cloud, or you can first go into GCE and then containerize your virtual machines. What's on the roadmap, and I've already said that, is the move from on-prem into GKE on-prem and moving the containers from GKE on-prem into GKE. Well, this might be possible with some tweaks. If you have already container, then you can use those images to deploy them into GKE, but it's not like straightforward thing to do. Okay, so to start with, let's have a look at V2V migrations. There was a product called Velostarata. It was a startup. It wasn't really, they created a tool for migration of virtual machines into GCP, and it was acquired by Google. Pretty good deal. And was rebranded into Anthos. So Anthos is basically, as Krzysztof said, is a suite of products for developers, but it's also, Velostarata was renamed into Anthos Migrate because they want to allow you to migrate from virtual machines into containers and make your workloads cloud native. Okay, when it comes to virtual migrations, you can migrate Windows and Linux virtual machines. It's completely agentless. You actually stream your virtual machines over WAN, so you can very quickly start your workloads. In 5 minutes, you have a workload running in GCP and the storage is being streamed from your on-prem. You can do tests, so simply clone your virtual machines first before even running it into cloud, see if it's working or not. When you're streaming, you can do rollbacks. So there are certain stages where you can see, okay, this is not working for me, I want to roll back. You can resize your virtual machines at the stage when you start running it in cloud, and also when you detach the virtual machine. And you have some runbooks and API, so you can streamline the migration. You can create runbooks, and once you feel comfortable with migrations, you can even integrate with like Ansible Tower or any other orchestrators that you have, and you can start migration automatically. And finally, you can do some bandwidth throttling so that you don't kill your network. Okay, and how does migration looks like? So, as I said, the first phase is the discovery. They said it's actually running like in sprints. So you have first week of discovery, decide workloads you want to migrate. You start running those workloads in cloud. So at this stage, you already have your workloads in cloud, and they're being streamed from on-prem. And in the background, you can start synchronizing the storage. Yeah? So here you have just the operating system cached in Google Cloud. And in the meantime, you can start copying the files over. When you are ready to detach them, you just detach them, and you have a copy in your own data center that's shut down, but you have the full virtual machine in GCP already. Okay, so here is how the process looks like. What you actually need to install on-prem is a Velostarata appliance. It's a simple OVF. It actually needs to have an access to the storage API of vSphere. This is how it gets access to the storage of the virtual machines, to the disks. And this is actually working on the storage level, not on the file level. You decide to run your virtual machines in GCP. You start the WAN streaming. There is a virtual machine created in GCP, and all the data, it's booted. So basically, it's streaming all the data from on-prem, and the virtual machine boots here. Whenever there is, and it actually starts here with the new IP, it's accessible from internet or internal VCP, depends on what you decide on. And whenever there are requests towards this machine, it would stream this data back from on-prem. I know it sounds a little bit like magic, but it works, and it's a proprietary thing developed by Velostarata. So that's basically in 5 minutes you have a virtual machine running in GCP, streamed from on-prem. Once you have this done, you can start migrating your data, or you can just keep this virtual machine being cached for, I think, two weeks. Then you migrate the data is synchronized. Once it's synchronized, you prepare to detach this virtual machine. You detach this virtual machine, this machine is shut down, and it starts running in Google Cloud. At this stage, you can still roll back. Once you detach the virtual machine, the data is recorded only here. You actually can set up, if you have this virtual machine here, you can set up if all the new data that is recorded here is going back on-prem or it's cached only here. It's your decision. Yeah? So until here, you actually have all the data stored back on-prem. I know it's, obviously if you have virtually heavy read, heavy write here, it might be difficult over the WAN, but for most of the workloads, it's functional. Okay, and a short demo of that. We have a recorded demo because, it takes a while to migrate virtual machines. Would take like an hour or so. It's very simple actually. You have a plugin for vSphere. You don't need to use Velostarata console. You simply click run in cloud. You decide on the name of the virtual machine. You decide on the size. You have some optimization recommendation in here. Here you decide if you want to write back your data on-prem. So you can isolate your writes into the cache in Google if you don't want to write it back on-prem. If you want, you just write back. So we'll have no data loss. And here a couple of things related to Google. So you decide on network tags related to firewalls. You can configure IP addresses where they should come from if you want an ephemeral IP address, external IP address. We do ask for external ephemeral IP address just to see if we can connect to that virtual machine in Google Cloud. Okay, we confirm, and the migration starts. So what's happening right here is that Velostarata, or Anthos Migrate right now, is connecting to the cloud extension in GCP, and it's creating a new virtual machine that and its storage will be streamed from vSphere. So obviously this took couple of minutes. So you can refresh. Here is interesting thing that you have this integration with cloud instance information. So here you can actually see in vSphere console, you can see everything that's happening with your virtual machine. And here is our virtual machine. So it took actually 5 minutes to create this virtual machine in GCP, and it's already booting. You can see the logs in Stackdriver. Let's see now if we can connect to this virtual machine with external IP address. So this was internal cluster. We got the IP from GCP console, and we tried to connect to it via PuTTY. And we can actually see that it's already available via internet. So at the moment, this is just streamed. What's cached in GCP is only the data that's required for booting the virtual machines and whenever we make the log. So all the rest of the data stays in vSphere storage, and you see that this virtual machine already doesn't have IP address. It has been switched off from vSphere, and it's served from GCP. And here you can go to Stackdriver, and you can already see the logs from the console, how the virtual machine was booted into GCP. And now what we will do is to migrate the storage. Sorry, just to show you the logs as well. So from the vSphere itself, you can also see the logs from the console. So it's pretty comfortable. You just install everything in vSphere. You don't need to use Velostarata console at all. Okay, the next step will be to migrate the storage. I think there was like 10 gigs of storage in there. We have speed that up. So we can see the progress of the migration in here. It's 40, it was started, storage migration 31. Okay, it took around 9 minutes if you look at when it was started and what time we had here. Okay, so the data has been migrated already, so it has been migrated actually, I think, to cloud storage, so the object storage. And now what we are doing is preparing to detach, so it will actually create an SSD drive, a persistent disk, in GCP that then can be attached to the virtual machine. Okay, and just to see if we still have the connectivity. So as I was saying, this virtual machine is still working. So there are only two times where the virtual machine should be not available. When you start running this in cloud, 5 minutes of downtime, and then when you start detaching it, it's going to be again a couple of minutes. And here in the Google console, we see that there is already the SSD disk created for us. And the detach, I think it's completed right now. Yes, it's saying it's ready. Okay, and finally, we should be ready to detach this virtual machine and complete the migration. So this is where, when we're doing the detach, actually a new virtual machine will be created, and the whole disk, the whole SSD disk will be connected to that virtual machine. We again have a chance to change the instance size. We will keep it as it is. And just to show you that put is not working anymore. The funny thing, well, not the funny thing, but the thing is that actually a new virtual machine has been created, so it has a new IP address. So we need to see, refresh it and get the new IP address to connect to it. Here you can see in the stack driver logs that actually the service account for Velostarata, you need to create a service account that will connect to GCP for Velostarata. You need to have permission to manage your virtual machines. So this is actually doing the operation on your behalf. So we are at the stage of detaching. And you can already see that the new IP address has been assigned. So let's take this IP address and connect via PuTTY to see if it's working. Okay. So we have this virtual machine now fully migrated to GCP. It's still, what's actually left is that the virtual machine is still managed by Velostarata in vSphere. So now you can do the cleanup by unmanaging it by Velostarata. And once this is done, you can either backup your virtual machine or you can just simply delete it. And from now, the virtual machine is running in GCP. Okay, and this is it's taking its time, but once you migrate a couple of workloads, then you can start running the runbooks. So we actually can define in CSV file. You can define what virtual machines you want to migrate and run all the stages one by one, and you can streamline those migrations. Okay, so now we're back in the console. And we have our Linux bITconf machine running in GCP. Okay, so this is pretty important to understand how Velostarata works, because that's the basis for understanding how it's used for migration from V2V from virtual machine to containers. Let's come back to the presentation. Okay, so V2K migrations, they have been presented in April, I think, on Google Next this year. It's early beta, and there being a lot of improvements done there. So I think in Google Next in November we can expect pretty cool things. I have already had a look at them. They're under NDA, unfortunately, but expect that this is going to be improved. So what I want to show you today is just to show the concept, what they're actually up to and how it can develop. So where we actually start is, again, virtual machine. Using the technology that I just showed you, you can start streaming the data into Google Cloud, and you can actually what Anthos Migrate is doing is converting your virtual machines into containers. So it would strip off the operating system, it would strip off all the stuff that's not actually needed for running this container. It will switch the operating system and will be just running only the binaries on top of it. What is it suitable for? It's basically suitable for non-production workloads at this time, yes? And this is being said a couple of times by Google. It's suitable for multi-tool applications, so obviously for those kind of workloads when you can define microservices. It's not it's suitable for small databases and low-duty workloads. What's important? You can migrate only applications running on Red Hat, CentOS, SUSE, Ubuntu, and Debian. Windows is currently not supported, but as you know, Kubernetes was announced for Windows as well. Let's see how this goes, but I don't think it's on the priority list. What's not suitable for high-performance databases VMs with some special kernel needs, obviously Windows, and if you have some special software requirements or licenses constraint, because it can cause problems with licensing. So how it starts, you basically have your on-prem workload. Let's say you have two virtual machines, app application virtual machine and database virtual machine, and you have your Kubernetes cluster set up already in GKE. And what will happen using Velostarata, you will move those virtual machines into containers. The kernel will be switched to the kernel supported by GKE, and you already have the integration with Stackdriver and Istio out of the box. So whatever policies you define, like with Anthos, this will be already working for your containers. And the whole process, from a very high level, how it works, you basically define a YAML file, that's the definition of your applications that you're going to migrate, and you don't talk to Velostarata. You are talking to Kubernetes engine directly. So by defining those YAML files, you're telling Kubernetes engine to stream the data of your virtual machine into GKE. And this data is cached. In next versions, you can expect that actually you can put those, you can export this cache. So actually you can, when you migrate, because this is, even if you migrate it, it's still cached from local storage in vSphere, but you will be able to export it and create images, put it in the container repository, and then be able to deploy how many pods you want and use all the Kubernetes definition. Okay, and then just a definition of this YAML file, so you can see what actually needs to be created is persistent volume claim. So this is basically defining what storage should be used by your containers. So this is using containers storage interface that was developed a while ago. This is abstracting the storage from your Kubernetes. And basically what you're saying, you're giving the definition, the MoRef of your virtual machine. If you use vSphere, you should know what it is. It's basically defining, it's ID defining your virtual machine. You define that you want to do streaming and kind of operation that you want, this test. And then you define a StatefulSet. So this is definition of your application that is stateful, so that has a storage connected to it and can keep the state. And what you have here is this annotation that is saying what disk it should use, yeah? So you're referring just to this name of the disk, and this container that will be started, it will be using this stream disk from your vSphere. Okay, so what actually will happen, as I said, this is the virtual machine. Once it's moved into GKE, the kernel and the drivers will be swapped. The login will be done using Kubernetes. The networking will be moved from the standard vSphere networking into SDN of GKE. And you will have persistent volumes that are defined in GCP. For the moment, they're streamed, but you will be able to export them in the near future. As we actually run out of time already, I think, but there is a really good session from Google Next where you can see this actually working live. I really encourage you to have a look at this. It's pretty amazing. They have a two-tier application that they're just moving from a virtual machine into containers, and they also define load balancer. So, you know, when you're doing the migration, you can not only define the application, but you can also make a definition of a service, which would be a load balancer, and you can deploy your application together with load balancer at once. And obviously you can define you can scale your application, define the number of replicas and so on. Okay, couple of resources, both on Anthos and Anthos Migrate. The sessions this year were really good on Google Next. So again, encourage you, I think we will share this presentation anyway with you guys. We would like to encourage you to visit Atos booth, and you can approach us after this presentation. We know we have time constraints, but if you have questions, just come to us. We'll be around in here. So come around, see what's happening in Atos. Maybe there are some job opportunities for you as well. The second thing is the Google Cloud bITconf community. So actually, if you feel like you need some more knowledge on Kubernetes, on Istio, we have a meeting on Monday. This Monday, just go to the meetup and sign for next week. We'll have 3 guys, 2 sessions on Kubernetes, 1 on Istio. The session on Istio is really cool. Using its, you'll see that the guy is actually showing you how to manage Istio using Google Assistant with no console. Pretty cool stuff. And finally, I would, if you want to learn something more about Google Cloud itself, I encourage you. We've been working with my colleague on a book. It will be released probably somewhere in November, hopefully. That will help you to work on your certification with Google Cloud. And also, if you have questions about certification Google Cloud, I encourage you to approach us. Okay, there should be a QA session. I'm not sure if we have more time. We have people coming in 10 minutes, so we need to be fair and let them in. But we're staying here, so approach us, guys, and wish you a good rest of the conference. Thanks a lot.